Okay, I am Dr. Babu, Department of Biomedical Engineering, Sri Sanmuga College of Engineering and Technology. Okay, today we can see surgical diathermy, the continuation of the surgical diathermy, that is illustrations of surgical diathermy. Okay, so the surgical diathermy, how we can illustrate? One is electrotomy, this is cutting. Next one is fulguration. The third one is coagulation, and the fourth one is desiccation. Already in the last slide, in the last class, the last PPT, we have explained about the surgical diathermy technique. What are the techniques? Cutting, fulguration, coagulation, desiccation. These are the some of the technique. So these techniques are illustrated in the 4 diagrams. In the screen you can see this is for the cutting. First one is for cutting, we are using the needle electrode. Okay. Second one is coagulation, we are using the ball electrode. Third one is fulguration, here we can use the needle electrode or ball electrode, a small electrode which is not touching the skin. A spark will be generated, superficial tissue only destructed, deep seated tissue will not be affected. And the fourth one is desiccation. The needle electrode will be stuck into the tissue, okay, pushed into the tissue, and it will be generated around the electrode. So that tissue will be, the color of the tissue will be changes, and it is called, the particular point the tissue will be destructed. It is called desiccation. So these are the some of the techniques: electrotomy, that is cutting, coagulation, fulguration, and desiccation. Okay, next one is homeostasis. Homeostasis is, it is the combined effect. That means it is also one of the technique which we are using in the diathermy. The concurrent use of continuous radio frequency current, which is used for cutting, and the burst wave radio frequency current generally which is used for coagulation, is called homeostasis. Homeostasis, we are using the concurrent use of the cutting frequency and also coagulation frequency current. The cutting current usually results in bleeding at the site of incision, where the surgeon would require bloodless cutting. Okay, in cutting current generally uses the bleeding at the site of incision. So generally we want, not only surgeon, we want bloodless surgery only. That's why we are using this kind of technique. The machines achieve this by combining the 2 waveforms shown in the figure. So figure will be shown in the next slide. The frequency of this blended waveform is generally the same as that used for the cutting current. So this is the homeostasis mode. In the hemostasis mode, we are using the concurrent use of 2 kinds of current. There is concurrent use of the cutting current and the radio frequency wave of the coagulation current. That is called homeostasis mode, to avoid the bloodless, that is blood leakage, to achieve the bloodless surgery in the diathermy. It is called homeostasis mode. Okay, now we can see advantages of using high frequency current. So generally I told you low frequency current is not used in the diathermy, only high frequency currents are used. So what is the advantage you of using the high frequency current in the diathermy? Okay, the separation of tissues by electric current always takes place immediately in front of the cutting edge and is not caused by it. Okay, the electric cutting therefore does not require any application of force. Without applying a big force, simply we touching the electrode or needle of the tissue on the tissue, so immediately the cutting process will be takes place. There is no need of applying the force to the electrode. Instead, it facilitates elegant and effortless surgery. Okay, very smooth surgery, That's why this is the advantage of the high frequency current which is used in the diathermy. The electrode virtually melts through the tissue instantaneously and seals capillary and other vessels, thus preventing the contamination by bacteria. So in ordinary cutting operation, okay, the bacteria will be generated and the tissue will be contaminated because of the bacteria growth on the cutting edge, the point of operation. But here we are using the diathermy, that is heat. Because of the heat, okay, the point of contact seals capillary and other vessels, thus preventing the contamination by bacteria. A simplified method of coagulation saves valuable time since bleeding can be arrested immediately by touching the spot briefly with the coagulating electrode. We are using the ball electrode, heating the ball electrode, where we are in the blood loss, simply we are touching the blood vessel so that immediately that point the bleeding will be arrested. Okay, that is the coagulation and the advantage of the high frequency current. Okay, in this slide we can see already we know that high frequency current, but what kind of waveform? So we are using the different kinds of waveform for different operations in the diathermy machines. Okay, not simply the sinusoidal wave. We are using the different waveform will be generated in the different machines. That depends upon the manufacturer also. Okay, in this diagram we can say A, B, two diagrams. One is both diagrams are used for the cutting operation. Cut waveform generated by the machines. Okay, in A, so in the diagram A, cut waveform generated by the electron tube circuit. Okay, in electron tube circuit, we are generating the waveform like this. This modulate just like a modulated wave. Okay, amplitude modulated wave. It is used for the cutting operation. Okay, this is also another kind of waveform which is used for cutting operation. This cut waveform generated in a solid state diathermy machine. As already told you, different kinds of waveforms are generated, okay, for cutting operation, and also manufacturer will select the different types, different waveforms. So different manufacturer of the machines, they will use the different waveform for the cutting. So some of the coagulate and blend waveform generated by the machine. So in this screen you can see the coagulated waveform and the blend waveform generated used for the homeostasis mode. Okay, so this is the first one. We are using the coagulated waveform which is used in the diathermy machine. This is called blended waveform. Okay, so the C, coagulate waveform produced by a spark gap generator, and D, it explains about the coagulate waveform generated in a solid state diathermy machine, and another one is blended waveform produced in a solid state diathermy machine. The third one is called the blended waveform. Okay, so it is blending of the two waveforms. So these are the different types of waveforms which is used for the cutting, coagulation and homeostasis mode. Okay, some important points to be noted in the diathermy. Okay, what are some important points should be noted in the diathermy, or what are the points you have to keep in your mind while we are using the diathermy machine for cutting, coagulation and any surgical operations. Okay, biological tissue can only be cut when the voltage between the cutting electrode and the tissue to be cut is high enough to produce electric arc between the cutting electrode and the tissue. Okay, and a sufficient electric arc should be generated. Okay, next one is the temperatures produced at the points at which the electric arcs contact the tissue, like microscopic flashes of lightning are so high that the tissue is immediately evaporated or burned away. So high temperature. Okay, generally what is the voltage is a voltage of 200 Vp plate voltage. Okay, a voltage of 200 Vp plate voltage is required in order to produce the electric arc between a metal electrode and a biological tissue. Metal electrode and a biological tissue. Generally we are seeing the 200 volt. If the voltage is less than 200 volt, what happens? If the voltage is less than 200 Vp, the electric arc cannot be triggered and the tissue cannot be cut. So that's why we are using the threshold value of the 200 Vp. Okay. Voltage suitable for cutting biological tissues generally ranges between 200 to 500. Okay, the minimum value is equal to 200. Generally we are using the maximum is equal to 500 voltage. So below the 200 voltage also it is not suitable, and above the 500 also it is not used. It will damage. Okay, if the voltage rises above 500 voltage, the electric arc becomes so intense that the tissue is increasingly carbonized and the cutting electrode may be damaged. Okay, cutting electrode will not move because of the tissue will be carbonized and getting clot. Okay, the cutting electrode will be damaged if we use continuously, if it is more than 500 volts. Okay, less than 200 volts, the electric arc will not be produced, so it will not be cut the tissue. A visible arc forms when the electric field strength exceeds 1 kilovolt per millimeter in the gap and disappears when the field strength drops below a certain threshold level. Okay, a visible arc can be seen. So from that we can easily understand whether the cutting or coagulation. Okay, biological tissues are coagulated by thermal means if the requisite temperature is maintained at 70 degree. Okay, this is the cutting. These are some of the points to be keep in your mind. Okay, what are the technical developments in this case? So in surgical diathermy, the recent technical developments or advanced technical developments are nowadays vacuum tubes and the spark gap units replaced. Okay, once upon a time we used the vacuum tube. The size here this is diode. The size is going to be very big. Cost also very high. Okay, electric power also, consuming power also very high. So once upon a time we are using the vacuum tube and the spark gap generator. So generally it is replaced by the solid state generators nowadays. So surgical diathermy we are using the solid state generators nowadays. Okay, disposable self-adhering dispersive electrode, that is called ground pads, are used instead of the large plate electrode. Once upon a time we are using the large plate electrode. Now we are using the disposable adhesive dispersive electrode instead of the large plate electrode. These are some of the developments in the technically. Okay, more safely the features are included in the design like dispersive electrode cable continuity, patient circuit continuity, path current monitors. These are the some advancement in safety features. Okay, frequency of operation of solid state diathermy machine is 250 kHz to 1 MHz. I already told you 1 MHz to 3 MHz we are using the generally for the surgical diathermy. But in solid state diathermy, the frequency of operation generally we are using is 250 kHz to 1 MHz, less than 1 MHz. They deliver 400 watts in 500 ohms load at 2000 volt in the cutting mode and 150 watts in the coagulation mode. These are the some of the technical specifications developed while we are using the solid state diathermy machine. Okay, in coagulation, the burst duration is 10 to 15 seconds and the repetition frequency of the burst is 15 kHz. These are the some of the technical developments developed. Okay, up to this we can see some about the surgical diathermy. Okay, some more advancement in this technical specifications we have seen. So up to this we can stop here and we can continue in the next PPT. Thank you.